The broadcast is now starting. All attendees are in listen-only mode.
Hello and welcome to the webinar. Today we're joined by Mitra Innovations Tech Lead, Dileepa. He'll be walking us through deploying WSO2 products on Google Container Engine. Over to you, Dileepa.
Thank you, Fraser. So hello everyone. Welcome to this webinar on WSO2 containers on Google Cloud Platform. My name is Dileepa Jayapuri. I'm a technical lead in Mitra Innovation. And in this webinar, we will be sharing our experience of deploying WSO2 products on Google Cloud in a containerized deployment. So this will be the outline for today's talk. First, we'll have a brief introduction about the company, and then we'll move on to the concepts of containerized environment like the containers, the Kubernetes artifacts, and then we'll take a look at how WSO2 have adopted these concepts of containers to deploy containerized applications on cloud environments. And then we'll take a look at Google Container Engine that we are going to use for our deployment. Then we'll take a look at the deployment process. The API Manager develop the deployment patterns as we are using API Manager as the product for this webinar. And then we'll take a demonstration of the whole deployment process. So Mitra Innovation. At Mitra Innovation, we help smart entrepreneurs, investors, and enterprises to accelerate innovative business ideas onto global businesses and solutions. We are specialists in product incubation, digital transformation, cloud-to-cloud system integration, and we are also We also have expertise on AWS and WSO2 as we are partners, a consulting partner with AWS and a WSO2 certified partner. So with that experience, with the expertise in WSO2, we engaged in an exercise of deploying WSO2 Kubernetes artifacts on selecting Google Container Engine as the cloud platform or the container engine. So moving on to the main topics, the containers. Containers have become a buzzword in today's software context, as it has brought about a lot of advantages to the application developers and also the DevOps engineers to deploy artifacts and manage artifacts in a very efficient and effective manner. So in theory, containers are a runtime instance of a container image, which is a lightweight standalone executable package which can encapsulate all the software components that you need to run a particular containerized application. So basically, it is an OS level virtualization which can run native applications natively on your Linux kernels. And also, containers are very lightweight and fast in comparison to VMs. And also, using containers, we can deploy applications in a portable manner, decoupling the application environment from the infrastructure. And also this helps developers to adopt agile application creation and deployment. The separation of dev and ops is another advantage for containers. And there are several main implementations of containers. Docker is perhaps the most important and the most popular one. And there are other implementations like Rocket, LXC, and unikernels. To give a better understanding of the difference between containers and VMs, if you take a look at this image, as you can see, containers have removed the hypervisor layer, which is used in virtual machines to run guest OSs, and on top of that, the binaries and libraries for each application. By removing the hypervisor layer, containers have improved the boot time rapidly. In fact, it has reduce the boot time from minutes to milliseconds in comparison to VMs, and significantly it gives better resource utilization in comparison to traditional VMs. So now we come to the WSO2 container world. So WSO2, as their container implementation, they have used Docker. So you can use their Docker files to build your Docker images from ground up and deploy them in Docker containers. So when we talk about WSO2 Docker images, you can have several options to deploy Docker images. One option is to build the Docker file from base images by using the GitHub repositories for each particular product. So they have Docker image repositories for each product, like API Manager and Enterprise Integrator. And also you can simply use the Docker images hosted on docker.wso2.com, which is their official Docker repository, and pull those images from there onto your container clusters. So if you take a look at the basic components of a Docker file, it is implemented in such a way that you can add layers of software on top of each. For an example, for WSO2 Docker files, basically they have imported the Ubuntu 16.04, the basic software layer, and defined WSO2 specific configurations as arguments, and then used a run command in Docker file to unzip the particular WSO2 product pack and configure the required configurations inside the Docker image. And then they have exposed the relevant WSO2 specific server ports like 280, 8243, and so forth. And then finally, they have given an entry point to give the default application to the Carbon script. So when we talk about Kubernetes, although Docker help us to containerize applications in a very effective manner, when we go to the production environments, we can't just use Docker and deploy containers in a clustered and managed environment. So that is where Kubernetes comes in. It is the open source container cluster management and orchestration system that was built by Google like 10 years ago, and it is currently actively supported by Red Hat, IBM, and other software industry leads like Microsoft. So with using Kubernetes, you can deploy your Docker images in all kinds of clouds, as it adds another abstraction layer on top of the physical implementation of the cloud. So basically, you can deploy your containers on all kinds of clouds. You can deploy your applications very quickly and predictably, and scale your applications on the fly using concepts like replicas, and also add rollout new features seamlessly using concepts like rolling updates. And also Kubernetes auto heals the container clusters so that there's virtually no downtime of your servers. So when we come to WSO2 Kubernetes, WSO2 Kubernetes artifacts enable you to run WSO2 products seamlessly on Kubernetes using Docker. So for this webinar, we are using API Manager Kubernetes. You can get the API Manager Kubernetes 2.10 version from this GitHub repository. And then we'll take a look at Kubernetes concepts that have been effectively used by WSO2 for their Kubernetes artifacts. For an example, they have used a deployment controller to declare the definition of the Docker deployments and manage and update pods. So here the pod is basically the smallest logical unit of a container. And then we have services, which is an abstract layer to access pods, expose internal endpoints to external traffic, and it also acts as a load balancer to load balance traffic. And implementation examples would be node port and load balancer. And ingress is a further abstraction layer of load balancer, which is actually a wrapper of an existing load balance implementation like Nginx, which gives more advanced load balancing mechanisms to your Kubernetes deployment. And then we come to persistent volumes and volume claims, which are very useful to manage persistent storage in containers, because containers naturally they don't have a persistent storage inbuilt. When you spawn up a new container, naturally the persistence is not there. So that is where persistence volumes comes in. There are many persistent volumes implementation like host paths and NFS, and using volume claims you can bind your containers to these particular persistent volume implementations. And then comes config maps, which is a relatively new concept in Kubernetes, which allows the product developers to decouple product specific configurations from the Docker images and apply configurations to products at the container startups. So this helps to simplify very complex configured products like if you take a WSO2 API Manager, it has many configurations that if you don't have config maps, you'll have to build the Docker image with the particular configurations inbuilt. So just by using config maps, you can build a very basic image of the Docker file, and then at container startup, use config maps to apply the configurations for the particular product deployment. So Google Container Engine is the managed environment for container clusters on Google Cloud. So it inherently supports Kubernetes as the container cluster orchestration framework, particularly version 1.75, and it also has a Kubernetes dashboard UI integrated. And then for using this Kubernetes dashboard, it basically gives a lot of intuitive dashboard to the application developers to manage the Kubernetes artifacts. Then you can also have Google Container Registry, which is inbuilt with Google Container Engine to store the private container images if you want to store particular private container images and deploy them in Google containers. So before we start Google Container Engine deployment, there are some software requirements, particularly if you are intending to build the Docker images from the Docker files. You'll need to install the Docker framework, Docker engine, using by looking at the installation guide on their official page, or install Google Cloud, and also install Google Cloud SDK, which is the general purpose Google client, which allows you to manage all the Google Cloud APIs and services. You can go to the cloud.google.com SDK documents to get the installation guide for Google Cloud SDK, and then you need to install the kube control, which is the command line tool for Kubernetes. You can install it separately or as a Google Cloud component in the Google Cloud G-Cloud tool itself. So in the demonstration, we'll be following these simple steps to deploy WSO2 API Manager Kubernetes on Google Container Engine. The steps is you first have to create a container cluster in Google Container Engine, then clone the latest Kubernetes artifacts from the WSO2 GitHub repository. So we are using Kubernetes API Manager project, particularly 2.10 version, and then copy the Docker images to the container cluster nodes. There you have several options. You can either pull the Docker images from the WSO2 Docker official Docker repositories, or build the Docker images from the Docker files and SCP the images to each and every node of your container cluster, or you can simply use the Google Container Engine, Google Container Registry to deploy your Docker images there and use point Kubernetes to use those Docker images in your Google Container Registry. And then you can deploy your Kubernetes artifacts relevant to the product by following the product's README in the GitHub repository. So the deployment workflow that we are going to follow is something similar to this. Here we are using the command line tools to deploy the Kubernetes artifacts onto Kubernetes cluster by using the Docker images hosted in the Docker WSO2.com Docker registry, and deploy it into Container Engine. And another option is, as I explained before, is to build the Docker images from the Docker files and you can simply SCP them to the Kubernetes cluster and deploy from there, or deploy your Docker images, host them in container registry, and point your Kubernetes clusters to use that images in the deployment. So in this demonstration, we are going to use WSO2 API Manager. WSO2 API Manager is an open source enterprise class solution that supports API publishing, lifecycle management, application development, access control, analytics in one integrated system. So WSO2 API Manager comes with a lot of different deployment patterns because it has many components like the publisher, store, API gateway, the traffic manager. So all these components needs to be deployed in separate servers in order to gain the most the performance and the availability and the scalability of a WSO2 API Manager deployment. So for that, they have defined different WSO2 distributed deployment patterns, which can be examined by going through the deployment patterns documentation in the WSO2 website. And for the demonstration purpose, we are going to start with the first API Manager pattern, which is the API Manager pattern 1, which only has one API Manager worker node and a worker node, and also an analytics node to connect and get the analytics statistics from the manage and work nodes. So then we'll move on to the demonstration. So the first step will be to create a container cluster in Google Cloud. This is the Google Cloud console. It is very intuitive, and all your required APIs and services, you can have it on your left-hand side tab. And I'm going to use the container engine, container registry, the compute engine services for this demonstration. So using the container engines, you can go to the container clusters and simply use the web UI to create a container cluster. So here you need to give a name. And I'm going to use the same zone. And you need to select the machine type for your for your nodes. So I'm going to use node type with 4 CPUs and 15 GB RAM. For the simplicity of the demonstration, I'll be only using one size of the node of the cluster, and then you hit create. Oops. Okay. Okay, this will take a bit of time to create the cluster. So in the meantime, I will basically show you how you can implement, configure the gcloud tool in order to run the commands to connect and manage your container cluster. So I will show you how I have installed. So the prerequisite is to install gcloud and kubectl for this exercise. So I have already installed gcloud and kubectl. If I going to list down the gcloud components, you will see that I have already installed kubectl and Google Containerized Docker credential helper, which is in fact useful if you are going to have your private repositories hosted on Google Container Registry. So I have implemented integrated kubectl as a gcloud component itself. Now, for the demonstration purpose, I will initialize gcloud CLI tool by executing gcloud init. Sorry. And then it will guide you through the configuration of the tool. So basically, you'll have to give the required configuration options. So it asks whether to reinitialize this configuration using this default config. and then you'll ask what is the account you need to connect. I'm going to use the djayakodi@mitra.com account, and then it will ask to pick a cloud project to use. So a cloud project is basically the umbrella project of all your containers and all the other services and APIs given by Google Cloud Platform. So I will be using Predictio project, and it also asks to whether to configure Google Kubernetes. I'll say yes. I'll use the default zone for compute engine, and now you are configured with gcloud tool. So yeah, so let's take a look at whether the container cluster has been already created. Okay, it's still getting created. So in the meantime, what I'll do is I will show you how to basically build the Docker images from the Docker files in Kubernetes API Manager project. So if I show you the Git repository that I have pulled the Kubernetes API Manager Git repository, and I'm connected to 2.10 branch, and there you be having this structure, the base file structure, and then you have different patterns organized in a very simple manner. So what you need to do is you go to the base folder, and there you have a basic build script which continuously build the Docker images required for the API manager, the base images required for any deployment pattern. So by executing the build script, you can build all the required basic images. Okay. So while it's getting built, let's check whether the container cluster has been created. Still getting created. Okay, this will take a few minutes sometimes. Okay, it has now completed the container cluster initialization. So what I'll do is you can simply connect to this particular cluster by clicking on this connect to cluster on the web UI itself. You can get this copied onto your machine and simply execute that on your command line to connect to this API Manager cluster. So now if you run kubectl proxy, this will help you to load the Kubernetes dashboard for this particular cluster. You'll go to local UI, localhost 8001 port UI, and this is the basic Kubernetes dashboard. So basically these are Kubernetes default namespaces and artifacts. So nothing we have deployed here yet. So as you can see, it's very intuitive to go through all the workloads, all the deployment artifacts of Kubernetes deployment. So when we want to deploy WSO2 artifacts on Google Container Engine, there are few tips that we need to follow that we experienced during our exercise. That is, by default, your storage class annotation of storage class beta Kubernetes IO default class is set to true on Google Container Engine's Kubernetes. So you need to make it false in order to make the persistence volumes to get created on your host machines. So make it false and update. So this is one minimal configuration that we need to do before any deployments of WSO2 artifacts on Google Cloud. And now we'll simply follow. Hold on. So we'll simply follow. Sorry about that, some disturbances. So we'll simply follow the WSO2's README file in order to deploy these images. So we'll use the Docker image pull method in order to pull the Docker images to the Google Container Registry, Google Container Engine. For that, you need to pull all these Docker images for each node in your container cluster. For that, you need to connect to each and every instance of your cluster. So you can simply go to the API cluster and go to the instance groups, and there you have the instance group, and there you can view the gcloud command in order to connect to that particular instance. Sorry, you have to connect with your username. Okay, now you are connected to the API cluster instance group, particularly one node, because we only deployed one node. Now you can simply follow the steps in the README file by first Docker login to WSO2 Docker repository. The password is this one. Okay, the login succeeded. Now you can continue with the Docker pull commands. I will be simply copying all the Docker pull commands at once and going to paste it here. So it will basically run through all the Docker pull commands for each and every Docker images. So basically, this will take a couple of minutes to pull all the images required. So as an alternative to deploying these Docker images from pulling the WSO2 repository, we can also use the built Docker images. So as you can see, we have successfully built our Docker images from the API Manager base images. If you Docker image, list down all the Docker images with WSO2 namespace, you will see there are the artifacts that we created a few minutes ago. And you can basically Docker save these images into a tar file and SCP all the files to each and every node and use that for the deployment, or you can use the Google container registry to host your Docker images and point Kubernetes artifacts to those images in container registry for the deployment. For that purpose, you need to do a bit of work here, because for Google Container Registry, you need to add this prefix us.gcr.io and the project name and the Kubernetes artifact and the version in order to make it available for Google Container Registry. So basically, you can Docker push this image to Google Container Registry. And it will be available in your Google Container Registry. So I'm having some access trouble for the moment, but never mind. We'll be anyway using the Docker pull command based method for the deployment. So while this Docker pull is working, we'll move on with the other deployments process as per the README file. First, you'll be needing to create a Docker create namespace in WSO2. You can create a namespace WSO2, and it will create a namespace in your Kubernetes cluster. Then you need to create a service account with the namespace WSO2. And service account has been created, and then you can simply deploy all your required artifacts using deploy Kubernetes sh. So if I go to pattern 1, because we are going to deploy the pattern 1 artifacts, in the artifacts you can see that all the required Kubernetes artifacts for API Manager, Container, API Manager Analytics, and required RDBMS and ingresses are defined in a very simple and intuitive manner. If you look at one folder, you will see in the API Manager folder you have the Manager worker deployment and the required persistence volumes and volume claims and required services. So I will also show you the deploy Kubernetes script. So this has an extensively listed all the Kubernetes artifact, the creation of all the Kubernetes artifacts. So we don't have to create each and every artifact by hand. We just can simply use the script. And deploy. So this will take a few minutes to deploy all the artifacts onto the Kubernetes cluster. In the meantime, you will need to work on another aspect in the Google Container Engine. That is another developer tip when deploying Google WSO2 artifacts on Google Cloud Platform is that you need to add a firewall rule in order to expose necessary ports of your servers, because by default Google Cloud doesn't allow all the ports. So if you go to the firewalls rules section, you can see that I have added API Manager rules for all the source IPs to open TCP port 80 and 443. So this is required in order to access the web UI of your deployed WSO2 servers. So it's taking a few minutes. In the meantime, you can access the Kubernetes dashboard and see what are the artifacts already being deployed. I will refresh this. So you'll have to have a the namespace already has got here because we created a namespace for WSO2, and there you can see that deployments, pods, replica sets are getting created for your WSO2 API Manager artifacts. So you can basically go to these pods and see their logs in order to see whether the services are getting up as expected. So it's very easy to monitor the artifacts using this the Kubernetes dashboard. So the services are still getting created. It's taking a bit of time there. So you can see in the deployment script all the configuration maps for API Manager specific different servers are being created. So with that you import all the specific configurations to the base image of API Manager for the deployment. So it's quite easy to manage the different configurations other than using some configuration management service like Puppet. You can simply use this config maps concept to basically configure your products at container startup. So the next step is to get the ingress, to get the external endpoint IP addresses. To do that, the Kubernetes deployment should finish. Still working on that. Okay, so now at the final end, it is getting the ingresses created. Okay, so as per the deployment script, the deployment is completed. You can see the ingresses here, or as also you can get the the particular ingresses in the console itself. Okay, the addresses are still not bound. We'll have to do a couple of time. Still the ingresses are getting created. So as you can see, we are using local host path persistence volumes. Which are bound to the host machines, this particular path as the persistence volumes. We will again check the ingress. Okay, now you can see that these hosts are exposing these IP addresses. What you need to do is you need to add these IP addresses and map this to the hosts in the etc hosts file. So for the sake of this webinar, we have already done that with a separate cluster deployment, because sometimes the servers are not getting up or started up in a couple of minutes, because it will take a bit of time for each of these WSO2 API Manager and relevant servers to start up. So what I have done is we have deployed a separate deployment on a separate cluster and match the host names for that IP addresses. So basically, if you go now to WSO2 API Manager publisher, you'll be able to access your publisher UI or console, which is running on your Kubernetes cluster. So we have also run defined few test APIs. You can similarly go to the developer portal or the store and log in. And if you need to kind of get this test API working, just to have a demonstration how it works, you get the production keys, generate them, and go to the test API. In the API console, you can simply invoke the API using the interface given. Very simple. Okay, so simply we have deployed a very simple countries verification API here. As you can see, you can give a country code and get a response from the backend API. So that basically covers the demonstration of our deployment. As you can see, all the deployment artifacts are now up and running. If you go to one of them and see whether the servers have started, you can just go to the pod and get the view log, and it says that the server is now having the console up and running. So yeah, so that's basically the demonstration of it. If you go back to the slides, to give a brief summary of what we did. So we just created a deployment on Kubernetes cluster on Google Cloud Engine, Google Container Engine. So this is a summary overview of what we did. So basically, you deployed a WSO2 API Manager pods for a particular pattern 1 in one node. So this is a single node deployment, and we can scale the nodes using replica sets to scale the deployment to multiple nodes, and then you expose the services to the external traffic using a ingress, which is a load balancer using Nginx. So basically that is the deployment of WSO2 Containerized API Manager product on Google Container Engine. And with that, we also took a look at what were the developer tips that we need to keep in mind when deploying WSO2 particular products on Google Containerized Engine. One is something that we didn't show you, is that the Kubernetes RDBMS deployment artifact, you need to add the MySQL argument ignore DB directory loss plus found. That argument needs to be there due to a known error, a known issue in MySQL Docker image. So if you I will show you that we have added that in the Docker file, and then you have to open the required ports by adding a firewall rule in the VPC section of Google Cloud Platform. And also you need to set the Kubernetes storage class annotation of default class false in order for the persistence volumes to get created. So just to give you an idea of the Kubernetes, the RDBMS parameter, I will show you that we have added it into the MySQL Docker file. Sorry, not the Docker file, Kubernetes artifact. RDBMS deployment. As you can see, we have added ignore db directory argument here in order for the deployment to work in Google Container Engine. So yeah, so that's basically the developer tips that we can give you in order to get the Kubernetes WSO2 Kubernetes artifacts up and running on Google Container Engine. And with that, we can go for a question and answers if you have any, and conclude this webinar. Thank you very much. If you have any questions, we can answer now.
That was brilliant. Thank you, Dileepa. We've had a couple of questions come through. If you have a look at the little panel, first up was Nalinda.
Okay.
Are they coming through? If not, I can just send them to you.
Yeah, I didn't get them still. Okay.
All right, that's fine. I'll just ping them to you.
Okay. So one question is, where would additional information go regarding API Manager cluster, the load balancing strategy within the cluster, and to make that cluster scale matching resource utilization stats? So basically, all the configurations of your API Manager cluster are actually defined in the Kubernetes artifacts. So the load balancing strategy, in terms of load balancing strategy, you can use the ingress artifacts with your particular load balancing strategy, I suppose. So you can configure the ingress artifact in order to get your load balancing strategy, if you answer that question. So yeah, that's one. Can incorporate config maps into a continuous delivery system so that we can automate on-demand deployment for WSO2 instances in an auto-scaling environment. Configure maps. Yeah, so basically you can have your configuration, different configurations into a CI, and have the Kubernetes deployment in a continuous integration manner. And also in the deployment itself, you can scale with new pods or nodes using replica sets. So yeah, to answer that question, you can incorporate config maps into a continuous delivery system to automate the deployment of WSO2 instances in an auto-scaling manner. Yeah. Need to the question of Anushka Samranayaka. Let's assume we need to archive all WSO2 carbon logs into Google Cloud Drive. How do we do that in archive all the WSO2 carbon? Okay, so for that, to answer that, we haven't done that in our exercise. What we used was we used the container logs. Basically, for each pod, the Kubernetes dashboard gives the access to your pods running logs. So we need to work on how to get that into Google Drive. So yeah, at the moment we haven't done it. So we'll be probably able to give you an answer if you drop. I can drop a mail to you to answer that question after trying that out. Containers are booting much faster than VMs. So does it mean a WSO2 instance deployed in a container will boot up much faster than an instance deployed in a VM? Yes, that's actually it will boot up much faster than a VM, because to start up a spawn a VM also it will need some boot up time. So with containers having a lean boot up time, you will be able to start up a WSO2 instance very faster than containers. But at the moment, the artifacts are actually I think not very optimized for containers at the moment. So the startup time doesn't actually reduce much dramatically than the VM startup time. So I think they will optimize the containers for WSO2 products in future, so that the container boot up time will actually be much faster than the VMs. So that's what that's my view. How many WSO2 container pods can be created in a single node of 16.6? So there is no boundary. So generally, in a single node, we, as a best practice, we did not deploy much pods in a single node, because that will basically not have a distributed setup. So basically, Kubernetes manages the pod distribution in the container in the container cluster. So actually, Kubernetes handles how many optimal pods that could be run on a particular container instance. Evaluate AWS ECS to deploy WSO2 product. Yeah, we did, and significantly we thought Google Cloud deployment was much user friendly and developer friendly in terms of the dashboards and the command line tools available from Google Container Engine as opposed to AWS ECS, because it was much very provider specific for AWS. So because Google Container Engine uses Kubernetes, it gives much more freedom in terms of scaling up or configuring the Kubernetes artifacts in order to deploy it on Google containers. So yeah, we thought as an experience it was much better than AWS ECS deployment. So yeah, I think that answers some of your questions. So if you have more questions, we'll be always they will be always welcome. You can drop a mail to our Mitra email address at djakodi@mitrai.com. So if you have further questions, please drop me an email. Thank you very much.
Thank you very much, Dileepa. That was brilliant. And thanks to all of our attendees today. We've recorded this webinar, so we will also send out a copy to you once we've processed that. Thank you very much for attending.
Thank you very much.